Namaskar, I am Swagata Ghosh in Radio Khanchi 90.4 FM हम सबका रेडियो from MCA course University Department of Mathematics Ranchi University Ranchi. I am going to discuss about the data warehousing and data mining paper which is taught in the fourth semester of MCA and in BCA courses also. The data warehouse, it was first introduced by William Inman in 1980. It is defined as the set of data, subject-oriented, integrated, time-variant, and non-volatile. The current or the historical data are merged into a single data store which can be used to support the decision support system. The data in the data warehouse are informational, which are used for planning, forecasting, identification of a trend. These are used in e-commerce, in manufacturing industries, business decision support system or business analysis, telemedicines, and in meteorological sciences. The motivation behind the data mining. The evolution in the information field took place after the voluminous incrementation of the data. It was first in 1960s the data were collected and it was stored in the databases. Then the evolution took place and during 1970s or 80s the database management system evolved and it took the advanced database, advanced system, and web-based databases. These were evolved, and further we got the subject called the advanced data mining. Implementation of data warehouse. These are represented as a cube or the lattice of a cuboid. Just imagine a cube which has got equal faces. There are 6 faces, and just if we tilt the cube, one of the corners is represented as a 0 dimension, also known as the apex cuboid, and it may represent one of any attribute. Let us take the example of the weather data, and the tip represent the total annual weather of suppose the entire world. The next level we go down, the next level which represent one dimension showing the single dimension attributes of any country of either weather or a season which are taken separately. The next tip of the cuboid represent 2 dimensions which is a combination of a country or season, country and weather, and season and weather. These are the 3 attributes which are combined. The base of the cuboid is computed to get the most specific cuboids of country, weather, and season taken together. The databases in data warehouse are modeled as a multi-dimensional table. The bulk of data are contained within a central table known as the fact table with no redundancy of data. That means there is no repetition. And the data are stored as the specific to the main theme and in the numeric forms also called a major table. The second table is known as the dimensional table, and there are a set of attendant tables, one for each dimension, and these are also known as the minor table. The arrangement of these tables in the data warehouse are known as schema. So we have star schema, which is represented in the form of a central table, and which is surrounded by a number of dimension tables in a radial manner, and they resemble a star. Each dimension contains one table, and each table contains a set of attributes. The data are unnormalized and occupy less number of tables, and here the operation of query becomes easier. The next type of schema is known as the snowflake schema, where we have a single fact table and multiple dimension tables. Some tables are normalized, which are splitted into more number of tables. This reduces the redundancy, and maintenance of the data is easier, but it affects browsing as more joins are needed to be executed. The, the data warehousing are used in the data marts. These are the small part of data mart. The third type of schema is known as the fact constellation schema. In this, there are two fact tables as in contrast to the previous schema of the star or the snowflake. Here we have two fact tables, and the dimension tables are allowed to be shared. These are used in the main data warehouse. So the tables are arranged as a star, as a schema, or a fact constellation. Next is the multidimensional data model. How the data are arranged in the form of a table, in a form of a flat files, as a database, and they are shown as a data cube. Data cube is a conceptual view of the data model which are formed of n dimensions and fact. Let us say, suppose the cube is represented as C with a subscription of A1, A2, A3 up to AN, and there are n dimensional data cube with attributes with A subscript AI number of distinct elements. The data cell in a cube, it stores the numeric measures. Means they are represented in the form of a numeric form. The dimension, the collection of logically related entities or attributes which are shown as an axis in the dimension model. Just we represent as x-axis. So let us suppose either it is a x-axis or the y-axis, which is known as a dimension. The dimension model is prepared on the basis of business or scientific concept. Here we took the example of a weather. So in a cube, let us suppose C, the cube C, we have three attributes: country, one dimension, season, another dimension, and weather, the third dimension. And the actual values are shown in the form of a data cell. For a country, we take the example India. For season, we represent as spring, and for weather, we take the temperature, because I'm not going to break down the weather attribute. So I suppose I represent 21 degree centigrade. So that 21 represent a parameter of the attribute weather. The lattice of the cuboid is shown as, imagine a cube, and one face of the cube, the lower part of the cube, represent the weather, where as a different parameters like temperature, pressure, humidity, wind. The another face, the vertical face for another side, represent the season, and we have the winter season, spring, summer, and rainy. Now on the top of the cube, this is again divided into 3 or 4 parts as the case may be, and we represent it as countries like UK, USA, UAE, India, Russia, and so on. So these analysis is done by the help of analytical tools, and the complex analysis of the data are done with the help of OLAP. It is the short form of online analytical processing, which is performed on the data warehouse or the data mart. It is a multi-dimensional operational view, and it is not a structure or a schema. And the main operations of OLAP are using the OLAP tools, and there are just simple query within a queue. So first operation is known as the slice, where just one dimension of the cube is taken. So let us suppose in my previous example, I take the example of a country for India. So that dimension will represent all the values of India. The second is known as the dice. We had taken in slice, there was one dimension, but in case of dice, we select it with the help of two dimensions, two or more dimensions, and we take the country, it may be India, or another attribute as season, which may be rainy. So the dice is represented as the horizontal bar on a cube, and which takes into account any two attribute, either the country or the season. Third operation is known as the pivot or rotate. In this visualization operation, the data axis is rotated to another axis. So if we had the values in one corner of the cube, after the pivot operation is performed, the entire data gets rotated and the values takes a round and it goes to the another extreme corner of the cube. The fourth operation is roll up. This is also known as the drill up. The operation performs an aggregation on the data cube. The central cube gets rolled up or it just gets climbed up the concept hierarchy, and a dimension reduction takes place. As we had shown, the different values of the country or the season of any particular country. Now if we roll up, instead of a country, if we represent the continent, in that case the operation of roll up will take place. The fifth operation is roll down, also known as the drill down. The operation performs a detailed navigation of the data cube. The central cube, it gets rolled down or descends the aggregation hierarchy. And where we had shown the season, in this rolling down operation, instead of the season, if we break the season in the form of months, where each season may have the duration of at least 4 months. So starting from January to December, if just imagine the cube gets rolled down and we have, instead of 4 seasons where we had 4 rows, when I represent as a month, this gets rolled down into 12 rows. Now this OLAP, online analytical processing, it is classified as a relational online application processing or ROLAP, or multi-dimensional online application processing, MOLAP, and third one is the hybrid online application processing, which is a combination of relational and multi-dimensional. The architecture of a data warehouse, it consists of 3 layers. The bottom layer, where we have the metadata, the data warehouse, which gets values from outside sources, from operational database or any other external values. These data warehouse and part of the data mart, they are carried to the next layer, that is the middle tier, and from middle tier the OLAP servers are there which operate upon the data and give the output to the top layer, which is visualized by the user, also known as the top layer or the top tier or the front end, and the data is represented in the form of a table, in the form of a flat file, as a chart, or any other graphical representation. The data warehouse or metadata, the data metadata is the data about data and which is been treated as an object. It works as a catalog, just like a catalog in the warehouse, and serve as pointers to the data. These are used in hierarchical relationship, stored formula for any computational analysis. The metadata repository, it contains the structure of the data warehouse, the data in operation for linkages, statistical calculations, and show the report of any errors. They also show the data aggregation, summarization, and granularity. The details of data sources, the gateways for data extractions. It also represents the performance of the system by describing the data. And the business metadata, which has been carried out during any business transactions. The metadata are of three types. One is build time metadata. These are generated at the time of the design and building of the warehouse. And this is extensively specified and detailed metadata that define the structure of a warehouse. It is used in the warehouse designers, it is used by developers and any administrators. Next metadata is the usage metadata. The metadata which are used during the production and used by the administrators and users. Third one is the control metadata, which are used by the databases in its own operations. Here the timestamps are used which track the sequences and timing of warehouse events that play a vital role in different warehouse. The data warehouse backend process. The backend tools and utilities which are used in various operations in the bottom tier of the data warehouse form the backend processes. The major functions are: first, the data extraction. The data is obtained from any operational or the external data sources. For example, the production data, the legacy data, that is the historical data, and of course the metadata. Second is data cleaning. The data that is obtained from heterogeneous sources that has to undergo some transformation. That means some unwanted or inadequate informations are separated and only the relevant data are extracted, and that is known as the refinement. The transformation rules are applied on those data. For example, anybody wants to change the age instead of the date of birth, because date of birth value is a constant and age is a variable. Second one is using any domain specific knowledge for any domain, let us suppose country. So for country which has got its own geographical extent, Second one is parsing and the fuzzy matching. A matching on the patterns are done with the help of parsing, that means forming a tree. And to search for any ambiguous pattern, an audit of the data is being done. Third one is data transformation. The transformation of the data from obtained from various heterogeneous sources to bring to a uniform structure, and then these are integrated. The fourth one is the loading. The numerous data when loaded, this increment to the volume of the data. It plays a vital role for the system administrator to monitor the loading of the data. So different types of loading are the batch loading, one by one. The second one is the sequential loading, one after another. And third one is the incremental loading. That means to carry the previous loading also and counting the aggregate of all the loading that has been done. And the last one is the refresh operation, where after every operation of the data warehousing in loading transformation, this has to be refreshed periodically. And the refresh policies are adopted by the administrator depending upon the user requirement and the way the data transaction has been carried out. The lecture note of this today's topic has been uploaded in the RU MCA app of the Department of MCA course, which has been prepared and administered by Mr. Abhinav Kumar, of student of MCA 6th semester. Thank you.